Good afternoon, everyone. So there's been a change in schedule because I actually have a flight to catch this evening, and I was concerned the way things were going. The talks were so good that we were going to overrun, and I would be spending an extra night in DC, which was not good for what I have to do tomorrow. However, it is a huge pleasure to be here to celebrate Bob's 80th and his many scientific accomplishments, and I really appreciate the opportunity, Brian, Jim, to come here and to participate in this. When I was thinking about what I actually wanted to do, initially I was a bit vague on what I should focus on. I decided, though, that perhaps the best way of doing this was to think about the intersection of my career with Bob's many activities, principally GSAS, but also a large number of rebuild workshops that we have co-taught over the years. So that's what I'm going to do. Now, many of you, well, not many of you looking at the audience, several of you know that I was actually a PhD student of our first speaker this morning, Tony Cheetham in Oxford. And my graduate work with him started in 1989, but prior to that, I was actually also an undergraduate thesis student with him. And in the 87-88 academic year, I was working on platinum, palladium, metal oxide synthesis. I did some neutron diffraction, and that was my introduction to rebuild. And it was not GSAS. It was a set of codes based on the Cambridge crystallographic subroutine library. I think it was like TFS LSQ or something, and then they were fine, but not great. And in the summer of '88, Tony, as he did for many of his students, came up with an opportunity. Why don't you go to Brookhaven National Lab, my first trip to the United States, and go and work with a guy called Walter Conman, Ocking Quick, some of you may know Ocking, and make superconductors. So I was supposed to be making copper oxides that summer. And I can tell you, I made absolutely no new copper oxides, but it did initiate kind of a lifelong series of visits to Brookhaven National Lab. So what did I do in that summer? Well, what I actually did was make a new platinum oxide. And like many platinum oxides, it was made by accident. I'm a firm believer, reviewing the platinum oxide chemistry literature, that what typically happens is you take a platinum crucible, you try to make something that doesn't contain platinum, and you make a novel platinum compound. I've seen this happen many times, and it happened to me. And I made this compound. Actually, whoa, that's the end of the presentation.
Well, I got through that in a hurry.
Yeah, absolutely.
Got us on
getting you back on schedule. So we made this compound. In fact, it was an absolutely awful twin single crystal. Solved the structure of that and decided that in order to publish, we needed to do better. And rather than try and get a better crystal, I made a bulk sample. Later on, went to ILLs. This is data from D2B, and used GSAS to perform the analysis. That was my ultimately first published analysis using the GSAS software. It was a huge improvement in usability compared to what I had been using. Now, this was interesting intersection with what I had done before, because I'd spent the prior year deliberately doing platinum and palladium oxide chemistry, and it turns out that this compound was structurally related to what I'd been working on as my undergraduate thesis project. So if we look at this material, you see it contains octahedral PTO 6 units, trigonal prismatic SRO 6 units, and they're these 1D chains packed together in a hexagonal array. And when you put copper in, you replace the strontium here. It actually goes into one of the square planar, roughly square faces of the trigonal prism, lowers the symmetry of the system. Nice structural problem. So we published that in '91, although the compound was made in the summer of '88 in Brookhaven. First GSAS. Okay, so Tony was really great on these summer opportunities. The following summer, it was, Angus, how about going to UC Berkeley? You seem to like going to the US so much. Go work with Neil Bartlett at Berkeley. Why don't you do some fluoride work? So Neil Bartlett, many of you may know, was renowned for his fluorine chemistry, particularly in relation to noble gas compounds. And the problem of the summer was the structural chemistry of ruthenium tetrafluoride and silver trifluoride. And silver trifluoride was a controversial compound at the time. There were several papers out there claiming different symmetries. There was no solid crystallographic characterization. Everything was out there, said it was different from gold trifluoride, which made no sense. But they had a new synthetic route to silver trifluoride. That is, the Bartlett group did. And the chemistry they're using is laid out here. For both of these two compounds, it's essentially the same approach. You make a salt of the metal in the right oxidation state. So this contains IUF6 2- octahedra. You abstract fluoride using a well-chosen fluoroacid, or Lewis acid, and I'll precipitate your solid. In the case of silver trifluoride, which is a really ugly compound, you start with a silver 1 material, you fluorinate with krypton difluoride, which is a better fluorinating agent thermodynamically than fluorine, it's made photochemically, and you make your salt. You pull off fluoride with boron trifluoride, another Lewis acid, precipitate out silver trifluoride, and you're in business. This is ugly. Handling it in the glove box, the inert gas, as you put it into the quartz capillary tube through experiments, it sparks. Mechanical friction causes decomposition, emission of light. It's wonderful. Wow. Anyway, so we took these materials initially to Brookhaven to visit Dave Cox on X7A to get some X-ray data. And the silver trifluoride data looked nice. We got a pretty decent analysis. The ruthenium tetrafluoride data looked less nice. This is a multi-phase sample. It's not very crystalline, but we can index this. I could solve the structure. It's isostructural with vanadium tetrafluoride. And Neil Bartlett was fairly pleased with this. He said, but the crystallographic parameters are not accurate enough. I really want to compare the details of these structures. You need to do better, Angus. Okay. So a year later, and having thought a little bit about how we were going to do better, it was to visit Bob at Los Alamos and HIPD. Because where are you going to get powder neutron diffraction data on next to nothing in terms of your sample? And they did not want to make multiple grams of silver. They really did not. I should say, I didn't make any of these compounds. They let me try. This was my first fluorine experiment, and I could say that they literally watched over my shoulders as I did it, and after a few missteps, decided I would be relegated to repairing the glass effect. I'm doing the crystallography. Okay, so off we went to Los Alamos to HIPD. So Bob was the instrument scientist on HIPD at the time. Sadly, Bob, I could not find any photographs of you from this trip.
Yeah, that's not me.
Not you. This is Bill Castile. And this is Horst Bormann, and they were a graduate student postdoc with Neil. So they were with me on the trip. I believe this is the HIPD pit. I'm not absolutely sure of that. And we are putting one or other of these samples into that instrument here. These are genuine photographs from the experiment.
Without safety glasses? Some very unauthorized pictures.
Statute of limitations.
Okay.
Statute of limitations is
Please,
expired.
I'm not going to tell you how the samples got to Leslie. Okay. Anyway. So this morning, Jeff, I think it was you, said small samples. I don't know what the order of these experiments was, but this was a small sample experiment. The data up here were taken on 50 milligrams of material, 20 hours of beam time. And down here, this was 100 milligrams, and that was 11 hours on HIPD. Okay, and Neil got the information he wanted. We got some pretty precise structural parameters out of those. And I'm just going to tell you a little bit about the structure of silver trifluoride and why he was interested in it. So the basic structure consists of AgF3 square planes. It's silver 3, D8, should be square planar, you might think. And these form helical chains running through the structure. So this is a chiral material. It's isostructural with the gold compound. And when you look at the geometry of the square planar units, whether you are silver or gold makes absolutely no difference. Okay? But when you look at these axial distances, they're very different. So this axial metal fluorine distance for the silver compound is 1/4 of an angstrom shorter than for the gold. There are various ways of thinking about that, but one way of thinking about it is in the case of silver, that DZ squared pair of electrons is held much tighter than for the gold, which is why you cannot oxidize silver 3 any further. Why silver 3 is already highly oxidizing. But in the case of gold, you can actually oxidize to gold 5 if you want. So this really reflects ultimately the chemistry of the metals. And these results were published in 1991. And I think this is the only paper I've ever actually co-authored with Bob. It's kind of sad, really. But that's the, you notice Dave Cox is also one. All right, so that's enough of the science. I'm going to move on to the teaching now. So Bob and I and many other people in this room have participated in over the years in numerous Rietveld workshops, short courses, whatever name you care to give them. One series that we both participated in were the Canadian powder diffraction workshops. They started off in Chalk River. I don't know whether you were in any of the Chalk River ones. I was at the second one, but I couldn't find any.
Just one.
Okay, that's pretty impressive. So I was at the second Chalk River one, but I couldn't come up with any photographs. For Waterloo, I did manage to find a photo. So there is Bob in the back. I might have been taking the picture because I don't appear in that image. We moved after many years in Waterloo to Trois-Rivières in Quebec. So here's a group photo taken in Trois-Rivières. That's Bob looking down at, I guess, the youngest member of the student body, something like that. And you might be wondering what this is. This is actually a sugar shack where they take the maple syrup and, the maple sap and reduce it to syrup. And we were there because the conference dinner was held in the restaurant across the parking lot from it, Chez Danny. And if you look at the actual dinner, you can see Bob in the back with a couple of my graduate students. And most people are actually looking at a group that were playing the spoons or some other musical accomplishment. Those meetings were organized by Jacques. A few years later, so I think we did 2 or 3 in Trois-Rivières, after Lachlan had died. This is Lachlan Cranswick. He was key to many of these workshops. Ian Swainson took on organization of the next one. And the time he was in Saskatoon setting up a radio pharmacy, he moved down to diffraction, but still organized this workshop. And I think, well, I'm not absolutely sure, in this group photograph, that's Bob. Did you miss the Saskatoon workshop? And this is the oldest participants in the workshop. Anyway, so we were in the geology department, I think, for this. All right, so we did many of these Canadian things. They ran from like 1992 to date. And we also did actually a lot of Rietveld short courses in Atlanta, Georgia Tech, which is my home institution. And these short courses were initiated by this gentleman, who I think Jeff also mentioned. This is Ray Young, the person that first developed Rietveld code for powder X-ray diffraction data analysis. And in 1996, Ray started organizing Rietveld short courses at Georgia Tech, and I was a young faculty member then. I started in 1993. Actually, as an aside, if it hadn't been for Ray being at Georgia Tech, I would never have applied to Georgia Tech. I was going through all these job ads in the back of CNEUs in the days when job ads were actually printed, and looking at all the universities I was going to apply to a job for, and I got to Georgia Tech, and I said, never heard of it, not applying. And I thought, actually, no, I have heard of it. Ray Young is there, I will apply, can't be all that. Anyway, so 2001, Ray's stepping back from organizing these workshops. I organized the 2001 workshop. Here's the group photo. Bob with lots of hair, Juan Rodriguez Caraval with, well, once again, Juan Rodriguez Caraval with a bit less hair, and Jim Kadick in the back with, well, not really. Never mind. Anyway, so this was the instructional team minus me, because I presumably took the picture. And here's Bob hard at work with the students in the computer cluster. Here is Jim with Yugang Zhang. Peter Lee isn't here, but at the time, Yugang was actually a postdoc with Peter at Argonne, if I'm remembering correctly. Okay, so I have managed to drop this completely out of the slide sequencing. But it doesn't matter, because basically all I've got left is to say thank you. I have really benefited scientifically from all that you've done, Bob, as has the whole of the powder diffraction community in the world. And I've really enjoyed working with you. And I wish you many more years of healthy and happy activity. Anyway, thank you all.